Okay, good morning. So let me solve this problem. This is problem 2114 in Origo book. So that's actually something very interesting. Might be I should have covered this in the lesson itself. So that's good that you asked the question. So you know that an equation for a line that passes through the origin takes this form, yes? Because you know that an equation for a line usually is of this form, kx plus m, do you remember? And m is the y-intercept. But when the line is supposed to pass through the origin, that m part is 0, so what is left is y equals to kx. So k is actually what is called the slope of this line. So k, from geometrical point of view, if you start changing k, what do you think will happen for the line? For example, if k is 0, y becomes 0. Yeah, so if the slope of the line is 0, and if the line is supposed to pass through the origin, when the slope is 0, it means that is a horizontal line, and because it is passing through the origin, y equals to 0 is actually the x-axis. And then if I start increasing k, what will happen? The line will start rotating. So it seems that there should be a relation between the value of k and the angle nu. This is the Greek letter nu, if I understood it correctly. I don't know if they mean v or they mean nu. Okay, here probably v. Okay, so this seems that by changing k, this angle is also changing. So this means that they are somehow related. And the point of this problem is to discover this relation. Okay, so I don't need to do it in 2 steps. We can just find the relation and fill up the gaps in the table in the first part of the question. Yes? Is the problem understandable? Yes? But I want to discover the relation between these two. So what can I do? Do you have any opinion about that? Okay, so let me take a random point on this line. Okay, so I will take a random point on this line, wherever it is. Of course, one point is 0 and 0, and then I take a random point here. If I want to write the coordinates of this point, I don't know the x-coordinate because I chose it randomly, but let me give it a name. For example, I give it alpha. Okay? Now, can you tell me what will be the y-coordinate if the point is on the line? Of course, I can write beta, but bringing more variables is not efficient in mathematics. You should be able to stick to as few number as possible for variables. So if I write alpha, of course I can write that y-coordinate is beta, but I am bringing 2 different variables, make problem harder for me. So I just want to write alpha, but can you tell me what can I write instead of beta, something related to alpha? Because this point is on this line. So if you know the x-coordinate, which is alpha, okay, can you tell me what is the y-coordinate?
K alpha.
K alpha, exactly. Because this point is on the line, so the coordinates should satisfy the line. So if x value is alpha, I put it here, y value becomes k alpha. Yes? Okay. But now, so if I write here, this is k alpha. Now, if I ask you what is tangent of nu, something interesting happens. So what is tangent of nu? Because this is a right angle triangle. Yes? So what is tangent of nu? It's the opposite side divided by the adjacent side. So very, very simple problem. So tangent nu is equal to k alpha divided by alpha. And I have intentionally chose this point not to be on the origin. So this is clear that alpha is not 0. So I do not have any problem if I put alpha in the denominator. But then everything becomes clear. So alpha, I didn't know alpha, but I really don't care what alpha is. Because whatever it is, it's going to be cancelled. So what is left for me is k value is equal to tangent of nu. And that is extremely important fact to memorize. I really recommend you to understand this. So now, For k value, we have a very nice formula. So the k value, or the slope of a line, is also equal, because you already know how to calculate the slope. If I give you 2 points, do you remember? You calculate the difference in y's and then divide it by the difference in x's. Yes, y1 minus y2 divided by x1 minus x2. This is algebraic way of calculating the slope. It doesn't give you the feeling of what a slope means, yes? But here you understand now, you have a geometric interpretation of the slope of a line. If someone asks you what is the slope of a line, you would say the slope of a line is equal to the tangent of the angle that that line makes with the positive part of the x-axis. Is that clear? So that is the relation between k and nu. So I answered the second part first. But now if you know this answer, you can come back and fill up those gaps. Yes? So for example, they have written something like this. This is a table, k value, v. So for example, they have put 30 degrees here. And they are asking you what the k is, what the k value is. That is clear. What is k value? K value, according to this relation, is tangent of 30. But 30 degrees is one of those famous angles. So you can refer to the table, which you will have it definitely in formula sheet. But I have it in my memory. So there are 2 ways of writing. Do you remember? I told you that this is also correct. I think your book has written this. But I usually prefer not to have a square root sign in the denominator. So I prefer to write this. Both of them are correct. Yes? So that is one. I don't know. The other one, they have written k is 1. And then you are supposed to find the angle. So what does it mean? Here, k is 1. So tangent of v, or nu, is equal to 1. Do you remember in trigonometry, in a right angle triangle, you can take your calculator and write it like this. But of course, this is one of those famous numbers. I told you that I don't expect you to memorize the content of those tables, but I want you to remember that these kinds of numbers are somehow famous. Otherwise, you will not be able to find them. So tangent minus, either you can use your calculator, but if you refer to that table, you see that, what is the answer? Do you know?
45.
45 degrees. So then here you put 45 degrees. Yes? And then, I don't know. The other ones are simple, I think. Okay, so let us, for example, go to the other one, which is written 2. I skipped the next one. It's easy. And then you want to find v. So what is v? Again, you write 2 is equal to tangent of v, and then this means that v is tangent inverse of 2. Okay? I don't know it's by, because I know that this is not a famous number for tangent. So what I can do, either, if I ask you to write it exactly, that is what I expect you to write down. And if I ask you to, for example, find it up to some decimal point, for example, 1 or 2, then you have to punch this in your calculator. And if you can help me, please, if you have any calculators, let us keep it to 1 decimal point.
63.40.
63 point 0.4 degrees. Yes, something like that. Is that clear? So that's the content. So I mean, the first part, you really don't need to do it first. I think this connection is extremely important to remember. Any questions? So for example, let me ask you one question. So do you know about the slope of vertical lines from your previous studies? So what is the slope of a vertical line? It is clear from this formula in Math 2C. So if I draw a vertical line, whatever it is, and I want to find so for example, assume that this is 5. I want to find the slope of this one. What is my goal? My goal is, what is my point? I have to find 2 random points there, okay, and read the coordinates, and then put the coordinates in this formula. But what happens if I want to do this?
Undefined.
It becomes undefined. Why? Because I don't know the heights. I have chosen them randomly, so I don't know the heights. But one thing is clear. the x-coordinate of this point and that point are exactly the same, 5 and 5. So let me call this one 5 and y1, which I don't know, but this is exactly 5 and y2. Yes? And then if I want to calculate the k value, what will happen? I have the difference of y's, but the difference of x's is problematic, yes? Because the difference becomes 0. So what does it mean? It means that if you have a vertical line, the slope is not defined at all. And that is also something, if you go through this lecture that I mentioned, so tangent of 90 degrees is also not defined, because if you have a vertical line, this angle turns out to be 90 degrees, and then tangent of 90 degrees is not defined. So that's a good connection between these from geometrical point of view and trigonometric point of view. So that is the whole idea of this exercise. But that is important. If I were you, I put this as a remark somewhere in my notebook so that I pay attention to it and remember it. Any questions? No? Okay. Okay, if you don't mind, let me just tell you something. Here, they have given this problem in the context of the trigonometry in the right angle triangle. But let me teach you a little bit around this. So what happens, so by the way, why is the horizontal line, when you say the slope of the horizontal line is 0, it means that if this is a horizontal line, k is 0. But it is clear, because when this is a horizontal line, nu is also 0. And this means tangent of 0 is 0. That is really true. So if you punch tangent of 0 in your calculator, you get 0 back. But one question that is not evident here, what happens if I make this angle to an obtuse angle? So this is between 0 and 90 degrees. And if I increase it more, okay, so what will happen? I will have this situation. I will have this situation, for example. Still, I can write x is equal to k, y is equal to kx. I just want you to test your understanding, refresh your memory. What is the difference between the k value of this type of lines and the k value of those types of lines? Yes?
It's negative there.
That one is negative, that one is positive. So if you want to have this picture in mind, that's not bad. So if I were you, I would write that this type of line, k is positive. Horizontal line, k is 0. This type of line, k is not defined. And then finally, this kind of lines, k is negative. So that's also good somewhere to have it in your memory. Okay, in this situation, what will happen? Be careful. The angle nu, don't think the angle nu is this one. The angle nu is this one. So in this picture, k is equal to tangent of nu, okay? So when you want to use this formula, it is extremely important. How do you measure the angle? You always should measure the angle from the positive x direction to your line, not the smaller one, okay? So if you take the smaller one, the tangent of those angles is always positive. So it is not possible, because you are, on the one hand, you know that k is negative. So if you take the tangent of this, it becomes what? It becomes positive, but you know that this is negative. Later we will learn that tangent of this angle is actually negative. So it is also good to write this so that you know how to use it properly. Okay? So that is something that's also good to know. I will also upload this as a video, okay? So because probably I will not solve it for the other group if they don't ask.